Now we want to discuss the questions on the second midterm. The first question say you got a table and you are required to find out the expectation, that's the mean and the variance, and then find out the covariance and coefficient, correlation coefficient, and try to figure out whether x and y are independent. Somehow, some of you missed the third question, say x and y determine whether they are independent or not. As a matter of fact, the rule to determine whether they are independent or not is quite clear, right? And we also have this question in the first midterm. To determine whether two variables are independent or not, the rule is that PA times PB should be equal to PA and B, right? Or, on the other hand, say it is a variable if they are independent, then covariance of A and B should be equal to 0, right? And if this is 0, then of course rho AB, that's the correlation coefficient, it should be equal to 0 too, because this one is equal to covariance of AB divided by sigma A and sigma B, right? So this will be the same thing. But somehow you want to be careful here. So if AB independent, then covariance of AB should be equal to 0, right? But somehow if covariance of AB is equal to 0, can you say AB independent? Yes or no? The answer is no. Why? Because covariance only deal with one kind of relationship, and it is linear, okay? It only deal with linear relationship. So if covariance of AB is equal to 0, that means they are not independent only under linear condition, because there are many other kinds of conditions, right? So somehow they may be independent in terms of linear relationship, but that doesn't mean they are independent. You have to inspect other kind of relationship. So this is the most comprehensive test, okay? If you want to know whether they are independent or not, this is the rule, okay? This is the rule. If you know the covariance is 0, does that mean they are independent? Not necessarily, okay? There will be some exception because this one deals with linear relationships only, okay? So let us get to the first question. We have a table here, x and y, right? So x is going to be 4, 2, and y, 1, 3, and this is 0.35, 0.4, 0.15, 0.1. What you get? 0.75, 0.25, okay, and 0.5, 0.5. So expectation of x is equal to, this is a discrete random variable, right? So it is equal to summation x times px. And I want to remind you, because later on we may use this kind of summation very often and two variables, so you want to pay attention here. This is a short form, okay? If I want to put down the whole thing, really it's I equals 1 to n, right? And xi pxi, right? And the same thing we want to get variance of x, okay? There are two ways. The first way is summation xi, okay, xi minus mu x times p xi, right? And I from 1 to n. But this should be square, okay? But we know that this is equal to what? Expectation x squared minus mu x squared, okay? So these are the rules, okay? The formula, if you know them, then everything should be fine. So in this case, what do we get? we get expectation x. Okay, I don't want to do any kind of calculation because you should be able to get it. So let me give you the answer. Expectation of x is 3. Variance of x is equal to 1. Expectation of y is equal to 1.5. Variance of y is equal to 0.75. Okay? And then we get to covariance. Covariance of x, y, okay, in terms of the formula, it is summation, okay, I from 1 to n, okay, and then j from 1 to, let us say is nx, and this is ny, okay? Why we use this? Because the number of x variable may not be equal to the number of y variable. But anyway, let us say it is the same, okay? So to make things easier, and it is xi minus mu x and yj minus mu y times p. Okay? It should be this. To put it simply, it is this: x minus mu x and y minus mu y, right? And what do you get? You get expectation xy minus mu x mu y, right? Okay? So basically, you have to plug in the numbers and try to get the result. So let us try this. Okay? First one is expectation of x times y, right? Okay? Usually, you won't use this. You will use this one because this one is simpler, okay? So x, expectation of x and y, right? X times y. So then x times y, right? X times y, 2 times 1 times 0.35 plus x times y, 2 times 3 times 0.15 plus x times y, 4 times 1 times 0.4 plus this one, 4 times 3 times 0.1. Okay? Remember, you have to minus, okay? You have to subtract expectation x and y. Expectation x times expectation y. So the answer is negative 0.1. Okay, it is negative 0.1. So what does that mean? What's the relationship between x and y? It is negatively related. Okay, negatively related. Okay, so now then you have to calculate rho xy, right? Rho xy is going to be negative 0.1 divided by square root of 1, okay? Because that would be sigma x, square root of 1, and square root of 0.75. And what you get? You get equal to negative 0.115, okay? Any questions on this? Questions? Okay, so basically if you know the formula, just follow the formula, plug in the number, okay? Plug in the number, and then you should be able to get it. Okay, let us get to question 2. Okay, so this is a sample on the tiles, okay? So the average for the tiles, average mileage is 66,000, and the standard deviation is 2,000. Okay? And we all know that when you purchase any products, the manufacturer, they offer you guarantee, okay? So it can run, say, usually you get camera, you get TV set. Usually the manufacturer guarantee them for 1 year, okay? But of course, if there's anything wrong during the guarantee, okay, you can take the product back to the manufacturer. They should repair the product for you free of charge. So because of this, you know, any kind of guarantee involves expenses, okay? There's cost to the manufacturer to offer such kind of guarantee. As a result, they try to reduce, okay, try to minimize this kind of cost as much as they can. So they want to find out, okay, when the product is defective, of course they have to repair it, but they want to make sure that this kind of situation won't happen more than 4%. Okay, so basically that's what this question is about. So you want to learn to be able to draw such kind of diagram. So this is 66,000, okay? And the question is, of course, if the product is defective, it has to be returned for repair, and then the company has to pay a charge. But they want to find out, okay, under what kind of mileage guarantee that they pay the cost only 4% of the time, okay? So what does that mean? That means they already know this is the number for the mean, okay? The average, the tires can last for 66,000 miles. But they want to make sure that any kind of product that may be defective is only 4%. And you want to figure out what's the critical point of that limit. So it should be here, right? And from here we know this percentage should only be 4%, right? So if you check the table, you should be able to figure out the corresponding z, because this is a normal distribution, right? But it's not a standard normal. So somehow you want to turn this number into a standard normal number, okay? And from there, you're going to figure out what should be the mileage, okay? Okay, so it turns out that what is the number of z? The number of z is equal to negative 1.75, okay? Of course, you check the table. The table only gives you a positive number, right? But you have to remember this is on the left-hand side, so it should be negative. So some of you made a mistake here, okay? It's a pity. It should be a negative number. So we know this number here is negative 1.75. Some people put down negative 1.76. That's correct too, because there is no exact number to match 4% here, okay? Anyway, so this is 1.75, and it should be equal to x0, this number, right? That's the number we try to figure out. And minus 66,000 and divided by, okay, the standard deviation, 2,000 there. So we know x should be equal to 62,500. Okay, so this is the number. Okay, so basically, if you understand what's going on in the question, then turn the words into a formula, then you should be able to get it. Any questions so far? Let us get to the next question. Question number 3. So in this case, we got a elevator, right? So these elevators can take 15 people or 750 kilograms. Okay? So 70 persons. But of course, If you got 15 people there, does that mean the elevator can take those 15 people? Not necessarily, because it also depends on the weight. If you got a lot of people that is overweight, okay, say 100 kilograms, usually, you know, for all of us, the average weight may be like 60 kilograms. But somehow some people are more than this, right? If you got all those overweight people, then the elevators won't be able to take them, okay? And let us say we have this kind of average weight for them, okay? That is, I mean, there are certain group of people, there are 15 people, right? There are 15 people, but they are Germans, okay? Germans. And you know Germans drink a lot of beer, right? So their stomach is like this shape, okay? But don't mistake, they are not pregnant, you know. So in this case, they got 15 people there, and the average weight for them is 75, right? Okay? And the standard deviation, so the mu x, 75, and the standard deviation is equal to 10. Okay, so the question is, what's the probability that the Germans, okay, they are, if these Germans, okay, they are 15 people, right? And they're gonna take this elevator, but this elevator can only handle 750 kilograms. Okay, so what's the probability that they will be out of the limit of this elevator? Okay. So generally, we're going to assume this is a normal distribution. So let us say we got the average is 75, right? This is the original distribution for one of the German, right? For the Germans. The average is 75, and the standard deviation is 10, right? So that means the variance is equal to 100, okay? So now we are talking about 15 people, not just one person, okay? We are talking about 15 persons, not just one. So we are actually talking about sample sum, okay? We are talking about sample sum. So in this case, we have 15, right? So 15 times 75, and then 15 times 100, because we know if x, the distribution is mu x sigma x squared, then the sample sum is n times mu x and n times sigma x squared. Okay? So basically what you're going to do is of course you know this is equal to 1125, right? And this is equal to 1500, okay? And now you want to know what's the probability, okay, that when these 15 persons take the elevator, okay, what's the probability is going to be overweight, over the limit of the elevator. So we know what's the limit. The limit is 750, right? So we want to figure out what's the possibility, probability that is going to be over 750, okay? And of course, we're going to turn this into a standard normal, right? Z greater than 750 times 1125, minus 1125, and divided by 1500, square root of 1500, okay? So what do you get? You get P is going to be greater than, Z is going to be greater than negative 9.68. So what should be the probability? Because when you check the table, can you find 9? No. But you know if it is Z, okay, is between 9.68, I mean 3.3, what do you get? You get 0.5. So what does that mean? What's the probability there? It should be equal to 1. Okay? Because it is from the very bottom here, right? Up to the whole thing. So the probability is equal to 1. So what does that mean? The elevators will reject, right? We'll get them out. The siren will ring, right? Okay, so let's The first type is, okay, whether they are equal to each other or not, okay? So let us say this one, okay, mu x is equal to 250, okay? Mu x, whether that is equal to 250 or not. And the other one is, of course, not equal to, okay? So these two must be mutually exclusive, okay? These two must be mutually exclusive. That means the two things, okay, if you're going to say probability, right? Probability of A and B, it should be equal to 1, okay, generally. And the other case, H naught mu x H1 greater than or equal to 250, right? And then mu x less than 250, okay? Then another one, still another one, mu x less than or equal to 250 and mu x greater than 250, okay? So basically when you get information from the manufacturer or whoever, then you're going to say, okay, I have to set up a hypothesis, okay, these two hypotheses, and then try to test what's going on in the, whether it is true or not, okay, to test whether that's true or not. So there are a total of 3 cases. In this case, okay, is two-tailed test. Okay, what does this mean? Two-tailed test. Okay, so this is 250, right? And of course, when you do this, you have to get a sample. Okay, you have to get a sample, try sampling, and then get information from the sample, and then to test whether the population gonna be this or this. Okay. If we want to test whether this one is equal to 250, then under some circumstances you won't believe in this. Okay. If it is too big, okay, if it is too big or if it is too small, then of course it should not be equal to, okay? If it is too big or if it is too small. So in this case, generally, the next step you have to get is the significance level, okay? In terms of significance level, the other term is confidence level. We already know confidence level, right? Because when we get the interval estimate, we say you are 95% confident, or you are 99% confident, or you are 90% confident, right? So confidence interval is that. And what about significance interval? That's 1 minus confidence interval. So if significant level, okay, we have significant level. If alpha, okay, if alpha is significant level, then what is confidence interval? That's 1 minus alpha, okay? So confidence interval 1 minus alpha, significant level, okay, that's alpha. Okay. Then how to test it, okay? What's the procedures that we should follow? The first one is to set up the two hypotheses, okay? The first one, set up these two hypotheses. And if this is what we're going to test, okay, equal, right? So from the significant level, from the significant level, you should be able to calculate the critical value there. Okay, so from the significant level, and if this is a two-tailed test, okay, this is a two-tailed test. From this significant level, we should be able to get the critical value at the right-hand side and also the critical value at the left-hand side. Okay? So this probability should be equal to alpha over 2. And this probability should be equal to alpha over 2. Okay? So in this case, because you have tried sampling, right, to get the value, this value from the sample, right, you get a sample mean from the sample. Okay? If this value is in this region, okay, so if the value is here or if the value is here, what does that mean? That means the probability for this value to fall into the confidence interval is very small, right? So if that is the case, if x bar 0, that's the sample mean, if it is in this region or in this region, then what would you do? You're going to say, sorry, because it is too big or it is too small. So do you accept this? No, you don't. You reject the null hypothesis and you accept the alternative hypothesis. Okay? But as you may know, this is all probability, right? We say, in this case, for this value to fall into here or here, the probability is very small. Okay? But indeed, it may happen, right? It may happen. So if you make this kind of decision, you may be right, you may be wrong. Okay? And so we have type 1 error and type 2 error. So let's get to the point here. Let us say, let me keep this part. Okay, so we have this may be true, right? Okay, and then this one may be true. Okay, and of course you have two actions, right? The two action is to take H naught, that's null hypothesis, as true, or take H1, that's the alternative hypothesis, as true. So A naught, A1, so this one is a and this one is okay. So if H naught is true and you think H naught is true, this is a correct decision. Okay, this is correct decision. And what's the probability that you're going to make this correct decision? 1 minus alpha. Okay? If H naught is true, okay, but you think H1 is true, so this is wrong, right? And what's the probability you make this mistake? Alpha, okay, and that is what we call type 1 error. Okay? Okay, H1. If H1 is true, but you say you take action A0, right? You take action A naught, okay? So this is a wrong decision because actually H1 is true, but you think H naught is true. So this is another error we call type 2 error. And this is, we call beta, okay, we call beta. And of course H1 is true, and you think A1 is true, this is a correct decision. So that's 1 minus beta. Okay? Any questions so far? Okay. So in this case, you know, sometimes you do it right, sometimes you do it wrong, because simply out of probability. So the only thing we can control is that we want to make sure that this one is a fixed number, but trying to minimize this number, okay? Because if alpha increases, then this one gonna decrease. If alpha decreases, then this one gonna increase. They are negatively related. So when we say negatively related, what does that mean? That means one going up, the other going down, and one going down, the other going up. Okay? So basically you want to remember all these pictures, okay? When you are confused, then try to put down this table to help you analyze the case. Okay? Any questions so far? Okay, so let us get to here. Because in this case we only see alpha, right? We only find out alpha. But there's no other things because we just mentioned beta, right? There's no beta here. Where to find the beta? Because beta is related to H1, okay? Beta is related to H1. And how can we tell here? So let us say we have two pictures here. The same thing, right? This is the left-hand side critical value, and this is the right-hand side critical value. We know this is alpha over 2, and this is alpha over 2, and this is 1 minus alpha, right? And this number is 250, okay? So let us say when you try to take a sample out of it, and then you find out, actually, the sample value is, okay, let us say we use a different number is equal to 245, okay? Because the company, the manufacturer say it is 250, right? But actually you find out it is 245. So you may be suspicious, okay? You doubt whether the company get the right number, okay, whether the claim is true or not. But really you find out it is 245. So in this case, the company believes that it is 250, but what do you believe? You believe that somehow it should be 245. So when we take this information into account, so this would be H naught. So when you deal with H naught, then you consider H naught as true. But when you deal with H1, okay, then you consider this is true, okay? So let us draw another picture here. Okay? And this is 245. And this is the right-hand side critical value here. And this is the same thing, left-hand side critical value here. Okay? So when you deal with this case, okay, this is 1 minus alpha, right? Okay, this is when you take action 1, okay? Action 1 means you believe in H1. But in this region, you believe you take action not, okay? And what's this? You believe in H not, okay? And here, you take action 1. You believe in H1, okay? So then, what should be this part here, okay? What should be this part here? Okay? When H naught is true and also you believe H naught is true, then it is 1 minus alpha, right? Okay? But now we are dealing with the second hypothesis. We suppose this is true. So if this is true, okay, and you take this action, if this is true and you take this action, what should that be? It should be beta, okay? So here, H naught is true, and you take action to believe H naught. So what you get? You get 1 minus alpha, right? But now you believe H naught is not true. So that means H1 is true. H1 is true, and you take action A naught. What does that mean? That's wrong. Type 2 error. Okay, so in this region, what is that? That's type 2 error. And what is this region? This area, let us say, it is A, and this area, let us say, it is B. So the probability of A plus probability of B, what should that be? That should be equal to 1 minus beta. Okay? Okay. And then, look at this. If you increase the confidence interval, okay? If you increase the confidence interval, that means this one will move to the right and this one will move to the left. So alpha actually will decrease, okay? If you increase 1 minus alpha, if you increase 1 minus alpha, that means alpha is going down. If alpha is going down, what does that mean? That means beta will go up, right? Because the direction is the same, right? If these two values moves out, then alpha goes down. If this area moves out, then this area goes up, right? Okay? So from this diagram, you know, alpha goes up, then beta goes down, and alpha goes down, beta goes up. Okay? So basically, that's the situation there. Of course, in terms of hypothesis, there are several issues here. Okay? Let's use one example, medicine. And of course, when we talk about medicine, we want to believe that that's effective, right? Usually, the company will say, my medicine is effective to cure some kind of disease, okay? Of course, whether that's true or not, that's a question, right? We have to test it. But generally, if you are the company, you want to say, my medicine is very effective in curing certain kind of disease. But what about if you are the administration, say FDA? What is FDA? That's the Food and Drug Administration. Administration. In terms of type 1, what is that be? What should that be? That is, okay? So generally, if you develop a medicine, okay, then you have to apply for patent, apply for approval to sell to people. So in this case, then you have two questions, right? One, whether it is true or not, okay? Then whether you want to take it or not. So generally, for the pharmaceuticals, for the pharmaceuticals, they have to test, okay? If they want to develop certain kind of medicine, they have to do first animal test, okay? And when the animal test is success, successful, then they do the human test, okay? So generally, there is a procedure that they have to follow. But now let us say we are concerned about whether it's true or not, okay? So for this kind of medicine, H naught, what would they say? They say it is effective, okay? The company say it is effective, okay? And H1, of course, that's not effective, right? And the same thing here. You have 1 minus alpha, and alpha you have beta and 1 minus beta. Okay? So now we have two persons. So let us say you are the pharmaceuticals. Okay, so you are the company, okay? And you are the government. You are the government. So what would you do in this case? So we say when you do hypothesis test, after you set up the hypothesis, then you have to determine the significant level, right? We say you have to determine the significant level. Okay? You have to determine a significant level. In terms of the company, okay, in terms of the company, what would you say? In terms of the government, what would you say? In terms of the significant level. And what means significant level? Significant level is when the medicine is actually not effective, but what do you say? You say it is effective, right? So this is A1 is true, H1 is true, right? H1 is true. But you say H naught is true, right? So this is A1. What does A1 mean? Alpha is type 1 error, right? And what is error? This error is, as a matter of fact, the medicine cannot cure any disease, right? The medicine cannot cure any disease, but what do you say? You say it can cure a disease, okay? So then when you are the company, of course, because if the patent is successful, okay, the most important thing is that if the government does not give you the patent, you cannot sell the medicine, right? If the government inspects it and say, sorry, it's not effective, okay, then in that case, what is going to happen? They cannot sell the drug, okay? And the drug means revenue to the company. So of course, the company will do whatever they can to get approval, right? So the intention is to get approval and then to get revenue, right? What happened to the government? The government wants to prevent a lot of bad drugs, okay? Some drugs, actually, they cannot cure any disease, but some people say, you know, this drug can cure liver disease, can cure influenza, can cure a lot of disease, but actually it doesn't. So government has a different perspective. The company focuses on money. The government focuses on the welfare, the health of the people, right? So they have different focus. So these two persons, okay, when they are dealing with the same issue, okay, they would have different kind of attitude, okay? They have different kind of attitude. Let us take a break. We'll continue next hour.